form of civil disorder. Somebody f***ing breaks something.
Okay, so today, first of all, I need to set this up. Alright, so what we're going to be doing, so yesterday I got to a point with this audio feedback where I think it's looking pretty good with the fast Fourier transform, but the Fourier transform, because it has to be a power of 2 to be fast, it's not aligned to each second, which I think makes this more noisy and less accurate. And so yeah, so I have the real version, the sine transform. I can do that brute force quicker than the Fourier transform. So that's what I'm going to be looking into. Like, this looks pretty good, but I still think it can be better. Other than that, pretty happy with it so far. Right here you can see the different frequencies. Just applying a blur to this would be really good, but yeah, anyways, I want the sine transform anyways, and it's good practice for these SSE and AVX intrinsics. So in this I'm going to be using SSE 3, SSE 1, SSE 3, and AVX, and I'm going to have all the different versions supported. So this macro, say it gets the CPU ID flag bits and checks if SSE or AVX are supported. I believe it's here, yep, okay. So CPU supports SSE 3, that's what we're looking for. So what we're going to do is if CPU supports, we're going to go backwards. So if CPU supports AVX, then SSE is 3. Else if it supports SSE 3, then SSE is 2. Or if just SSE is supported, then it's SSE 1. Otherwise, it defaults to SSE 0. So then, SSE also requires an alignment of the data. So what we're going to do is do if SSE. Let me just make sure this is it. Yeah, I think this is good volume. Then if SSE does not equal 0, we need to set an alignment. So for AVX we need an 8-byte alignment. Oh, hold on. 1 sec, my cat is here. Still moving my desks and chairs around in this room and getting it set up, and I put my chair down where my cat lies down, and my cat was pissed. So needed to fix that. But right now I'm using a rocking chair. So I have another chair I'm switching out, but I actually have to wash the padding first. So yeah, waiting for that. Alright. So then... call this SSE version, or I don't know what to call it. Dimmed? Yeah. Alright, so then, right here we need to do, if alignment does not equal 1, we need to do malloc aligned. First let's do normal malloc call. Alright, so what this actually is going to come to is going to be size times 2 times the size of floats. So we need one buffer for the sine, one buffer for the inverted sine that has a different scale, and that's actually all for the sine transform. So that's just 2 times the size times 4 for the float size. And then if we have alignment, we do malloc aligned. Our alignment. And then, okay, actually, so I'm going to need to do 2 malloc aligned calls for this. For each of these, I believe, because each need to be aligned on their own. Unless I do the alignment myself, which is much harder than just doing 2 malloc aligned. But it's faster, more efficient. It's an easy way to align with pointers myself. Yeah, I'm gonna need to align it. Anyways, so I will do a different alignment system. So I think I'm actually going to do this without SSC or anything first. So this is just sine b plus size. I think I can still initialize it using this. And the difference with the sine transform is the frequency is actually 1 plus I. I'm actually going to do this, wait, what am I doing trying to optimize this? That's why I'm pre-computing this, is for the optimization. It doesn't really matter what I do here. So it's I times m pi, size of 1. Then we can it is a lot more efficient to turn this into one multiplier like this. And then we just feed that into sine. And the difference with this one is that this one will have a scale on it. So 2 divided by size 1. So there we go. And then, I won't account for it now, but if there's the alignment here, I'm going to need to fill in. There's going to be some empty values at the end here. I'm going to need to fill in with 0 so that I don't mess up the calculations. But I just want to test this first without SSC or ABXer. So I'm going to disable this. I'm going to do SIMD equals 0 here, so even if it supports it, it doesn't use it. Then we're going to create our sine transformation function. Just going to take in a source and destination. I'm changing it up from how this worked before, as well as a boolean saying if it's inverse. So then what we do here is we loop through all the frequencies like this. We have our sine values, which if it's inverted, we use the inverted values, otherwise it's normal. I'm just writing this without SIMD to start, or SSC and AVX. So this whole thing works by summing. So then we loop through all the values of the input again, adding them to this sum. Like this, and multiplying them. And then to optimize this non-SSC and AVX version, what you can actually do is divide size by 4 or 8 and do multiple of these operations in one, which is what I think I'm going to do. And then you also need to say what ones aren't aligned to 8. So size minus size 8 times 8. So then this turns into that's 8, I plus, and then in this you do this 8 times. Five, 6, 7, 8. So the way this optimization works is that if you imagine what this compiles to, is this compares if this value is smaller than this. If it's not, it jumps to the next part of the code here. Otherwise, it runs the code in here, which is adding and doing our operations, and then it goes and adds the I value before it then goes back and compares. So if you think about how small we're doing here, we're just doing an add and a multiplication and getting from some pointers and incrementing some pointers. This is nearly just as many operations as this is. So you basically have like an overhead for each of these. If you do these 8 times for each of the 4 comparisons, you end up getting much more bang for your buck, or making more use of the processor cycles. So then we need to go through and do the ones that aren't aligned to 8 though, like this at the end. And there we go. So then our sum here contains the result that we then write to the destination buffer, just like that. Boom. So one of the things I am looking at though, this would all work much better or much more optimized for the SIMD. I'm gonna need the source to be aligned to have the buffer alignment. So yeah, SIMD might be really hard for this. We'll see. Anyways, I've got this little example code here for the Fourier transform that we're going to also go and change to a sine transform test. There's something wrong with this C project. Shit. No additional include directories. std int.h. We got malloc. Malloc.h. Or wait, actually. cmalloc stdlib, I think it is. stdlib.h. Alright, here we go. There we go. Prints out testing, just making sure everything compiles right. Now we're going to code a small example for the Fourier and sine transform. So float data with sine wave of frequency. What frequency? Let me just make sure I have wavelength right. Wavelength. All right. Create a macro for, or a function for printing floats. Alright. Then after this, or I think above we might do the sine transform because it might actually be simpler. Just test this to begin. Sine data. Alright, sick, it gives the correct result back. The Fourier transform is working. I think I'm gonna scale this data though. Or remove some fixed points from it. Looking at how the period works for this sine transform. There we go, that's better. There we go, sine wave goes up to 1, then back down. And we can see here the values match up. I'm just looking at the Fourier transform spectrum. It seems correct, giving you large amounts of lower frequency. I want to see what the sine transform spectrum looks like though. Alright, then we'll do the inverse. Alright, here we go. Now this will run the sine transform forward and inverse. Just a big fucking thing of numbers, holy shit. Alright, that's broken. Why is it doing a C printf float? What does a money sign mean when you're printing floats? Is that not a number? By the way, I gotta spread out the data. This is more correct though. You can see it's got a giant reading for the low frequency. It's got barely any high frequency. It's just incorrect here. What are these? Just gonna print the raw results. Almost think I'm doing more spaces between them. Oh, yeah, here we go. Not a number. It was just cutting off the not a number part. Okay, that's what I was looking for. I'm just printing out all these values just to make sure none of these are not a number. Nope. Oh my god, I'm so stupid. This includes all the different frequencies. Holy shit. I need to look at this old code I have for it. Sine transform old. Right here. So you can see it doesn't just loop through one frequency of sine waves, it loops through multiple. Oh, I'm so dumb. That's what I'm supposed to do. Yeah, this uses way more memory than so this actually becomes, I think it becomes size times size. Oh yeah, I'm doing some hardcore optimizations here, but I can't really compare. Maybe it is size times size. So that's m pi divided by frequency. And then the scale is actually the same for all of these. I'm surprised this wasn't crashing. This was reading into a whole bunch of memory I haven't allocated. But I guess that's C. Okay, here we go. There we go, except it has the wrong values. Right here. It actually seems close to correct. No, actually it's off. Not sure if the scale is lower or what. I think that's still wrong. Oh, this is supposed to be plus T size. Oh, here we go. It's not perfect 1-to-1, but it is matching up. So this is super complicated. This isn't a good example for most people. Most people this will just fucking destroy their brain, but it does show you how to use the sine and Fourier transform. So there we go. Boom, we got basic sine transform. Now, the goal is to turn this giant loop of add multiplications into a much better brute force using SSE and AVX. So we can do, with AVX we can do fused multiply and add, fmad, to multiply and add 8 floating point numbers at once. So we can optimize this, even though it's brute force, we can do it a whole bunch. So just to reiterate why I'm doing this, this is some complex mathematical stuff, but the fast Fourier transform only works with powers of 2. Size must be power of 2. This is due to the way the optimizations work. And so then if you're not doing a power of 2 Fourier transform, you can't optimize it even close to as much, and you have to do the brute force method, which complex numbers are a lot slower than real numbers. The sine transform is the real number version of the Fourier transform, and the Fourier transform uses complex numbers. So, at this point, the sine transform for us actually becomes much easier to use, because now we can use any value. So for example, with the issue we ran into was we're dealing with audio data that's 48k kilohertz. And then our Fourier transform, for example, if we wanted to get the frequencies over for example a second, just to be simple. So there's 48k samples per second. Let's say we wanted to do a Fourier transform over this, or a fast Fourier transform. We couldn't. The closest power of 2 to this, if we go into programming, we can actually look at the bits here. So this last bit here closest power of 2, we can see 32K is the closest power of 2. But if you then look at that, the 32768 divided by 4800, that means our Fourier transform spectrum isn't across a second, it's across 0.68 seconds. So this causes massive issues where you can never actually get a perfect segment of frequencies. You need to do non-powers of 2, whereas when you can do that, you can just pass in a straight 4800 frequency spectrum, or in my case, what we're going to do is we're going to do 1/10 of a second, which will be 4800 divided by 10, 4800 samples. So then we can actually get direct, perfect 1/10 of a second frequencies. So this is like, you normally don't have to do this stuff, but I'm just trying to get the transformation perfect. So the first thing we're going to look at implementing is the normal SSE, no SSE3, just SSE. So I have this labeled as SIMD equals 1. So for this, we're going to need to do alignment, which is where this is going to get really complicated. I honestly think the alignment here is more complicated than the actual SSE and AVX code, so we'll see how this goes. But basically what I have to do is the start of each of these frequency arrays, I need to have them aligned to 4 or 8 bytes, which, sorry, not 4 or 8 bytes. What am I doing? This actually needs to be aligned to 16 bytes, this needs to be aligned to 32 bytes. So that's something. Anyways, one second, I'm gonna go get some food, I will be back in a second. I'm also gonna think what the best way is. So, one thing is I can do is I can go through and calculate the alignment of each of these arrays, so basically add padding on each end. That's probably what I'm going to end up doing, and then I can do one big malloc call. Okay. So yeah, I remember this is what I did for the neural network, as I calculated the size with the padding, or the padding to match the alignment. So what I can do here is, I'm going to do the alignment as number of floats. So 8, 4, so then we need to calculate the align size. So then the total size now becomes align size times size. And then we multiply that alignment by 4. That's the number of bytes. And all this still works the same. Awesome. Okay. Actually, I like the way this code looks. And I can use the same code for right here. And then I could do padding. So then this tells me how many zeros I have to put in here at the end to pad the alignment. That's the align size minus size. There, that should be it though. Then right here I just do loop through the number of padding and just fill this in with zeros. Okay, now for the real issue. This source data, to load it effectively, needs to be aligned. So I'm almost wondering if doing an alignment variable here Yeah, I think that's the easiest way. If I just included an align variable here, it was like the same thing as this. And then that way you know if you want to allocate these buffers. When you allocate these buffers, you need to do it aligned. Yeah, okay, let's try this. So, if AVX if SIMD equals 0, I'm going to do this here without SIMD. If SIMD equals 1, then we just need the normal SSE right here. I feel like I should just do SSE3 and no SSE1, because basically everything supports SSE3 now. Yeah, that's the whole thing. I'm not gonna program. I think programming it 3 times is enough. Programming it 4 is a bit much. And we can also set the alignment right here. There we go. I feel like I should do an aligned size variable too. I think a vector size. I wonder if I should add the option if you want to use SSD and AVX, just in case you don't want to worry about vectors and alignment. This is our memory aligned buffer. Okay, so the first thing we need to do is load in the way this is gonna work... Okay, actually, I'm gonna create a function or macro for allocating these aligned buffers. Use sign transform move buffer needing alignment. Oh yeah, I'm gonna actually need to do align. Alright, there we go. That'll allocate a buffer. Okay, now I know I can read or do load PS. Load 4 floats in. Just like how we have the source pointer here. And actually we do the same thing here with the sum. I'm writing to distance at the end. Load SP. Oh wait, and AVX is also gonna need FMA. FMA. Wait. There's an SSE FM add, right? Yeah, so I'm gonna do this with AVX. And SSE3 is just gonna be SSE3. No fused multiply add. Alright, so we have to multiply the source by these vectors. Load PSSV, and we're actually going to store this in a buffer or in a temporary variable. So that we can then do horizontal add, sum them. Remember to include the headers. Alright, so then I should be able to repeat hadd twice, and it should add each adjacent variable. Let me see, CSSE is horizontal add slower. Add slow. Let me just make sure. That doesn't even use horizontal add. So I believe the way you do this is this. I'm actually wondering if this is less efficient than just reading out the values and adding them up. I could actually test this. Yeah, there's nothing like testing it. Let's do a quick test. This data. let's test this. Oh shit, it works. Okay, now let's see if it's faster. How am I gonna do this? I guess repeating it over and over again. Try repeating it a million times and see how long that takes. Oh, I didn't include system. And also I should make sure this doesn't go too overboard. I'm going to add a little bit of overhead to make sure it doesn't overflow, and also to make it just take a little bit longer. Yeah, so that's what I was worried of. It'll execute in 0 milliseconds. Result. It might be optimizing this out, but unless I print the result. Oh yeah, here we go. 3 milliseconds for the float. We'll do 100 million iterations. 282 milliseconds. Actually, wait, I think there is SSE get single value. Oh, I just realized I can actually use the horizontal add. Get a better result. need to shuffle. Okay, yeah. I think the most efficient is just to have aligned memory ready. I wonder actually if it optimizes together this. Since data never changes. Yeah. Okay, I'm actually going to do this differently. Yeah, I'm actually not sure that the compiler isn't optimizing this out. I should have actually done random values here. Either way, I'm sure the horizontal add is quicker, especially once I'm stacking up. Or I can stack up. Yeah, so I'm doing this wrong, doing the horizontal add right here. What I should be doing is saving the sum as a vec4 and then doing horizontal add on that at the end. CSSE is set faster than load. Okay, so unaligned is a little bit slower. I think though, because this is using set, it's faster. And I think there's a set all. Do the lower element and 0. PS1 broadcast. This is what I'm looking for. Initialize sum to 0 and then add this and then add multiplied values and then we increment the pointers. Boom, we're good. So then right here what we have to do is we have to sum equals horizontal add. You know what? Horizontal add actually isn't crucial to the optimization of this, so I think I might just do normal SSE with no horizontal add, because then I can support way more CPUs and there's very little difference in the optimization. The only change is this turns into and then store and then we sum them right here, which is still very fast. Alright, so this is the SSE version of this code. So now we just need to do the AV. Okay, actually before we do that, we should test this. Does this even work? The memo line on the data. think I don't have to do oh yeah, because it's inverse, I do have to do it here. I wonder if this does Memeline on this too. I'll try, see if Memeline works here. Yeah, that's what I thought. Alright, let's see if this works. No, incorrect results. So, alright, this stuff is so hard to read. I apologize, but the goal here is this sine wave data. You want to run it, it wants to run through the sine transform and then inverse, and the inverse should be equal to the original data. So you can see here with the Fourier transform, this is the frequency spectrum, but then the inverse, 0.2, 0.4, 0.58, it's the same as the source data, 0.2, 0.4, 0.58, 0.48. So we're trying to get that with the sine transform inverse, and you can see it's giving Nada numbers. So there's something wrong with it. I think it might be the memory alignment here. A said who? But I'm not sure. Let me just try this. Doing SSE. Oh, I'm not doing sum. Oh my god. This is supposed to be sum equals. I guarantee that. Basically what it was. And there's no printf function here. Wait. It just gave me an error for the printf function. Different linkage. Where did that come from? I wonder if that's Microsoft Visual Studio messing up. That's weird. Whatever. Okay, no, not a number. It's still wrong. Oh wait, there is not a number. How loud is this music? Pretty loud, but... Let's say it was doing... Alright, let me fix this error. Why is it giving a printf error? Redefinition, different linkage. Are you kidding me? Hey Scallywag, I'm trying to optimize this brute force sine transform with SSE and AVX instructions. Okay, wait. Let me just try something. Define. I think I had code. I think I ran into this issue before. Wait a minute. Malloc. Not include stdio. Okay, so that fixed it. That's weird. I guess that makes sense though. Fuck it, let's roll with it. Oh, wait, it didn't print out. Hold on a second. Printf supports SSE. Printf supports AVX. Oh, I see what's wrong. I'm not actually setting it properly. Supports AVX, doing SSE 4 times. Oh, here we go. There we go, it works. So you can see, oh my god, and so the sine transform, it's really hard to tell if you don't really understand frequency spectrums, but these first numbers are lower frequencies, and these later numbers are higher frequencies, and our sine wave is a very low frequency. You can see the wavelength is basically goes up to 1 halfway across, and then goes back down to 0. And you can see the sine transform basically gives you one big lower frequency and gives you a lot of the data. It's a really accurate measurement of the actual frequency spectrum. Whereas if you look at the Fourier transform result, it has spread out these frequencies across the higher frequencies as well. Oh my god, I swear to god this sine transform is going to be so much better for visualizing the audio. Because it really, the real number, I think it might be because it's real numbers instead of complex. I'm not going to pretend I know exactly what's happening here. Anyways, now that we know this SSE code is working properly, we can go on and do the AVX. Copy this, doing AVX. And now now the vectors are 8 size. Single precision floating point element from A for the resulting dist. So I think this is actually best if I extract the single element after doing the horizontal add. That should work. Okay. So then I don't even need this. So this becomes a 256. Basically just put 256 in front of everything. Oh yeah, and I get FM add. Then add the intermediate results, packed elements in C. Boom. There we go. Oh my god, this is actually going to be really fast. Or it looks like it's going to be really fast because it can deal with 8 of these components at once. So then this becomes... Just need to make sure this actually has a horizontal add. It does. Oh, okay, so I gotta think about this. You have to repeat vec4 version 2 times. So this is like swizzling the vector each time it adds. Convolutes it more and more, so I have to do like horizontal add, sum. So at this point, you'll have like x equals x plus y, and y equals z plus w, and then like z is equal to x plus y and w. It's like, yeah, you can see right here what it's adding. And then if I repeat it again, it'll combine 4 of those, and then repeating it a third time should do all 8. Okay, so I should have to do it 3 times. So 1, 2, and then at the third time we're going to extract what is this? Extract 128. Extract 128 bits. No. Oh, I think it's just EPI 32. Extract 32-bit integer. Now there has to be a way to extract. Oh my god, is there actually no extract? Extract 128 bits from A. Okay, so you have to do this extract 128 and then do the extract or can you just cast this to an integer? Let me actually look this up, because I believe I could just change this. I'm going to go a bit faster to store to the stack. And then do scalar loads. I wonder if the horizontal adds actually aren't fastest. Extract load. Do. It also extracts one of the 4 integers. To efficiently extract floating point numbers, you need to use functions. They extract only the first floating point number. Oh my god, okay. Yeah, this stuff is very complicated. CVT, these are the functions I'm probably looking for. And it doesn't... Oh, yep, there are 256 versions of these. Okay. What I'm looking for, convert F32. Copy the lower single precision floating. Oh, this is exactly what I'm looking for. Yeah, okay. Hell yes. So then when we run that on the result of this horizontal add, it'll give us the same result as adding up the values of these 8 vectors. Okay, that should do it. Size 4. Oh. Initializing can't convert int to n fix. Oh, there's no set PS1. For the AVX 256. Okay. I feel like seeing that they only have this instruction here, that set PS is actually the faster version. Do that right here as well. Unresolved external symbol. Huh. Did I spell this wrong? CVTSS F32. I wonder if this is missing from Microsoft Visual Studio. Missing some AVX instructions. Yeah, and this is from 2018. Yep. Filer tells me this isn't found. Oh, Visual Studio, why do you do this? I guess it makes sense though, this is pretty new. Like this stuff is... So I'm actually thinking instead of doing all this horizontal add stuff, I should just do exactly what it does right here. Let's see though. I think there's a way to convert. See, this is the thing though, I could do all these functions to convert between them. Or I can just do what I know works and what I know will be very fast, storing in an already aligned memory position. I'm just going to do that. Can't use a new compiler with old Visual Studio. That would cause a bunch of issues, I think. SSC convert. Decided to make a post about on Reddit. Hope it goes well. But probably get lots of publicity. Like posting on Reddit, I think is a really good way to get clicks. is there a cast? I guess it would be called cast instead of this is cast. Cast vector type M56 to M28. This intrinsic is only used for compilation and does not generate any instructions. Holy shit! Wait, can you just cast these then? Oh my god. So yeah, this is exactly what I need. Sick. Yeah, okay, here we go. So then I can just do convert S. Take this code back. Then I can just do the old convert S by casting that. And then that should be supported. Boom, there it goes. Okay, let's see if this works. Doing SSE 4 times. There's something wrong. It's not doing AVX. Oh, I'm still setting it right here. Doing AVX 2 times. Yeah, and it's wrong. It's wrong! Okay. We will break this down. We're gonna not do this horizontal add just in case this is the problem. We're gonna do what we know works. So the people post your algebra libraries. Other one wasn't really thought out though. The math.h is pretty nice, but it has problems too. I gotta be honest, I don't know. I don't really look at a lot of other math libraries. Unless I'm looking for how something works. Alright, let's see if this works. Oh, that did work. So it's the conversion at the end that was breaking it. It was that optimization I was trying to do. Wait, hold on a second. What mic is my PC using? Huh. Alright. Hold on though, I'm gonna go get some water. Now that I know this works, it's just something that's happening here. I've got to think about it.
Would be the pentagram or the inverted pentagram on the right and the left side of the upper chest. This oftentimes is the signature of the high priest.
Oops, I did not mean to turn that off. Okay. So, this is really stupid, seeing now that the error actually comes... I'm actually wondering if the error here is coming from this conversion, this new conversion function or cast, or if it's coming from the horizontal sums. We're going to try doing the horizontal sum. And then not doing the conversion, we're going to try storing it. So this will show if the horizontal adds are working or if I'm not doing enough horizontal adds. Oh, yeah, that's wrong. So it's the horizontal adds that are wrong. So yeah, I must not be doing enough horizontal adds. Look at how this is working. Yeah, I think I need to repeat it 4 times. No? I wonder if 2 times is actually... Oh, I didn't mean to do that. What did I do? What is happening here? I actually think I'm gonna write out this test right here because I'm honestly no clue what is happening. So we're gonna write out a simple example here. That's where we have the data aligned. Oh my god, it's not aligned. Maybe that was the issue. Maybe the data isn't aligned. No, because it was working otherwise. So we're going to do these operations and then we're going to print it out again. See what it actually does. Because with no operations, unresolved external symbol. 56 store. Oh, it's not 2 underscores, it's 1. One to 1. Then we'll add in a horizontal add here. I wonder if I actually have to convert to the 128 vector after this to do it proper. I'm actually thinking, looking at that, to do it properly, I'm going to need to do that cast. to the VEC4. Oh no, there we go. So after, yeah, it just takes 2 horizontal adds and it sums them. That's actually really good, oh my god. Okay. So... then why isn't this working? Let's add some... Yeah, so it works correctly when I just sum them all up like this. But as soon as I try to do the horizontal add, I wonder if I need to set, I wonder if I need to pad this distance. I don't think so. Dude, that's so weird. I don't know why this works when I write an example up here, and it doesn't work when I do the horizontal add right here. I mean, it's not that big a deal if I have to do this, but it is bugging me that I don't know why it doesn't work. So I think I'm just gonna say screw this. I'm just gonna print out what this FVEC is. So this print floats variable is there. And then I'm just gonna print out the floats for this. We know what it's actually doing. 0, 465. Yeah, so it's added them all up correctly here. It seems like. Oh my god, you know what I didn't check? I didn't even check here. It's adding up the same. So is this equal to Hey Keith. Man, I looked up that what is it, looked up Ramadan Steve. I have not watched, fuck, what's his face? I've completely forgotten the dude's name now. Eric Andre, yeah. Oh my god. Fucking Hannibal. So good. Dude, this is Big Dick C coding right now. This is SSE and AVX. Oh my god, it is adding up the wrong values. Shit. Wait. Horizontal add doesn't do what I think it does. No. Wait. This doesn't make sense. So this horizontal add is different than this horizontal add? Let's look at this. Wait, hold on a second. 2.1904 times 2 is... Oh my god, it has the result just divided by 2. That's weird. That's weird. Why does that happen? I guess it's the way it adds them up. That's weird though. So then, I know how to fix this. So this just needs to be multiplied by 2, I think. No, that's not it. Oh my god. Two apps made for school so far using Cordova. Running a lot of JavaScript. JavaScript's good though. It is what basically everything uses nowadays. App I'm working on right now is like offline Instagram. So it's like a photo gallery. I don't know what's wrong here. Let me see if this actually lines up. So this times 2 is equal to the sum. But I wonder if I cast. Oh man, I don't know. I should probably just be doing this without the horizontal adds. But I can't help but I want to learn this because this stuff will also apply to the neural network optimization. Code gallery with comments, or with local storage in the browser. Cordova essentially is. This is the native web view for Android and iOS, so you can use local storage for info for your app. Yeah, and Windows and everything has a web view now too, and I'm pretty positive that the consoles, like PlayStation and Xbox, are using web views for all of their user interface. Like, I know PlayStation uses WebGL for their interface, which makes me think it is a web view. Yeah, everything is using web views when they can now. I was gonna suggest ×2, but you didn't, it didn't work. Yeah, it works in this example, but it doesn't actually work in the result here. Which makes me think my data, let's try some different data here. Zero, 1, 2, 3, 4, 7. Sum is 28. Oh, I am not doing enough horizontal adds. Let me look at this. This is why I wasn't understanding the function. So no horizontal adds. It's the same data. One horizontal add, and it swizzles 2 each on each side. Two horizontal adds. It's got them each on each side, and then if you add these up, you get the sum. So you gotta do 3. Oh, I'm just not doing enough of this. Wait. What the shit? Oh my god, okay, I see what the issue is. It doesn't properly add up. At this point it goes and adds up 6 again. What am I supposed to... I think at this point it's just best for me to just do 2 of these, or maybe even 1 of them. Then add 1. Yeah, no, okay, so what I think is most efficient is if I do 2 of these horizontal adds and then add these 2. I'm wondering though if I can cast it to, I don't want to load the whole vector just to add up two values. I know there's no different horizontal add. So I think what I'd have to do is cast a lower one. I think there's one that takes the upper vector and lower vector. AVX 256 cast upper bits. Now these conversions just do, yeah, shit, so I think I have to do a bit shift. AVX sum all values. Screw it. I should just copy this code from Google on how to do the fastest. Improve efficiency. Extract 128. Oh, this is what I'm looking for. .56 extract F128. This is the exact thing I'm looking for. Extract 128 bits of the upper half. Let me see what this person does. I feel like this might actually... Yeah, the horizontal add I think is still best. So, horizontal add, and then I think what's actually best to be doing now, if we do this convert and cast, so we cast the lower half of this, or we cast it to a vec4, which gives us the lower half, take the float from the bottom of that lower half, add that float to the float from the lower half of the upper half vec4 of the vec8. Man, this is fucking ridiculous. Oh my god. Okay, this should do it. Sum 28, sum 28. Oh my god, okay. Well, I feel like I learned something. Now applying that here. Got our horizontal sum. Actually, shouldn't have deleted that. Just copy this code. Oh my god, okay. This is it. This is gonna work, I'm calling it. The data's wrong, hold on. It did work though. 0, 1, 2, 3, 4, 5, 6, 7. Do it with a sine wave. Intense. Yeah. Yep, there we go. Perfect. 0, so the original data is 0, 0.2, 0.4, 0.58, 0.74, and then you can see the sine transform is 0, 0.2, 0.4, 0.58, 0.74. It's perfect. Perfect. Okay. So now this gives us a way to get perfectly aligned frequency spectrums for our audio visualizer. So the whole reason I did this is for this audio visualizer here. This uses the Fourier transform right now, but the issue is the frequencies actually aren't aligned to the samples. It's hard to explain, but like basically what it means is these frequencies are actually jittering back and forth and aren't an accurate frequency bin. That's, oh man, it's fucking complicated. So the sine transform will let me evenly divide like a second into like 10 parts and get frequencies for all of that. So I think I'm gonna, now that this works, I think I might move over to fixing this up again. I'm not sure though, because while I'm looking at this, I'm like, maybe I'll do some more examples here. What data do you transform? In this example, it's just a very low frequency sine wave. In that audio visualizer, it's audio data directly from Windows. So it's like a full system audio visualizer that just visualizes whatever audio is coming out of your speakers. So I need to erase these comments. Placeholder code. Alright, there we go. That file is ready. God, I don't know if I want to work on the audio visualizer right now. Go down that rabbit hole or do something more simple. I might do something a bit more simple, do like a physics example here or something. So transform and plot. I'm not even plotting, I'm just outputting. You just see here, I'm just outputting the raw values. The raw decimal values. I am I'm very simple. I do, you know what? That's actually something I need to make an example for. That's a good point. This graphing class here. An example that shows how to graph. Oh my god, I forgot I added text rendering to this. Well, shit. That's nice. So maybe I'll do that. Create an example for some of these. Oh yeah, I used to have examples for like saving PNGs and things. I didn't mean to send you to work, and I need to do this stuff anyways. I'm not, I'm really bad, I'm releasing this, but I'm not going to I haven't looked at generating documents yet, is there's absolutely no comments or summaries. So instead I've written these examples that show you how to use each class and function. And then it tells you stuff like look in list.h. So that's why I'm making these examples, is they're really the only documentation I have for some of this code. And I think examples are the best way to document it, because it literally shows you how you can really copy and paste parts of these. Like if you want to generate random numbers, you just copy this. I'm actually wondering if I should change this from 2018 to 2020. It makes this shit look old when I have 2018 on here. Comments are key. See, that's the thing though, like, let me go back to the code I was just writing here. Like, trying to explain what it's doing here with the memory alignments, like, this shit, like, I would have more comments than I would code here. If you copyright examples, then they can just copy and paste it though without your license. Yeah, I mean they can, but that's the thing though, it kind of bets on me suing them. Realistically, like, I'm not gonna send lawyers after every random person that copies this and doesn't include a license. But yeah. Like, that's the thing though, when I write a bunch of this code that's just math, I don't know how to describe it other than the math itself. Like, if I was writing a description here, it would literally just be like, for loop summing the sine wave coefficients. And like, that's the whole thing. This isn't gonna help people. This already says exactly what this does. And like, write a LaTeX document. Yeah, that's what I was kind of talking about, is that realistically, for an engine like this, I would do summaries, like, you do summary like this, and then you run it through like Doxygen, and it'll generate a LaTeX document and documentation for all that. But that's the whole thing. I haven't designed it around that, so I would have to go through and add summaries to everything. And then with the way C works, this is the other issue with C, is my structures and functions are like loose. Like in C++ and C# and other languages, you'll have like the functions defined in the structure here, so Doxygen can then automatically go, hey, these are sine transform functions. But the issue is when I do Doxygen on my C, all my C files here, it literally just gives you this giant list of functions, and it doesn't automatically sort them by classes or structures. So it's one of the huge issues, and kind of what made me look for other forms of documentation like these examples. And then like there's stuff like this graph image, where I honestly think you should be able to understand this yourself. New graph image of width and height. Clear graph image to a color. Let me code up an example for this. So this graphing example is actually also going to be an example for this bitmap helper, because I'm going to save the graph as a bitmap image. I'm just creating a new Visual Studio project here. I just copy an old project and rename it, because Visual Studio sucks and doesn't give you an easy way of duplicating projects. Alright. And Visual Studio creates these SDF files that get really big, so I just like to delete them after each time, just so they don't add bloat. Does Doctigen support math latex? Yeah, I'm pretty sure it supports nearly everything. I think there's actually some better software than Doxygen now. I just haven't looked into documenting stuff for a while. Okay, so let's start. Create new graph image, our canvas for rendering our graph. We're going to make it 800 by 600. And then we're going to do graph image clear, clear white background. White is just all one. And then just to test and make sure, we're going to do save BMP image to bitmap image file. Graph.bmp. I'm actually looking at this. I'm writing this and loading this from a file. I should maybe do this through a stream, through the stream class. That would be the ideal thing. I know why I did this though. This was a copy of the PNG helper file that implements zlib, and this only works from a file. So I was just copying the same thing. So that makes sense. Anyways, you can just call save bitmap, pass in a pointer to the graph data, and then the width, height, and the bits per pixel, which in our case is 24. Let me just make sure, is it bytes per pixel or bits per pixel? Okay, it's bytes per pixel. Yeah. Okay, so this should output a, forgot to include malloc.h in this. Actually, stdlib. Yeah, right here. Okay, stdlib. Too few arguments. Oh, I forgot. Also the width and height. Unresolved external symbol clamp 01. Oh, I forgot. I removed that, changed it with just this general clamp function. Okay. Oh, oops. Gotta open up another console to do this. Alright, here we go. So graphing.exe saves a bitmap file, 100 by 600, and boom, it's all white. Okay. So now we're going to do some actual basic graphing. We're going to draw a grid to our graph using this right here. It's going to go from the left side to the right side. The rad is the radius of the lines. We're going to do 2 pixels, and they're going to be black. And I think we're going to do ten lines across, or maybe 11. Alright, so now this should draw black grid lines. At the end of this, we're also going to output graph to now here, save to graph.bmp. So now you can see we've got our graph with grid lines. You can see they're kind of stretched across the x-axis. It's because it's 800 by 600. I actually forgot about this. This is a good reason to make your graph an even thing like 500 by 500. Alright, there you go. My cat was just sneezing. Kinda scared me. Alright, now we're gonna... I don't know if we're gonna draw a graph, or I think I might draw a bar graph using this box in the draw box and draw some text. Draw bar graph of sine wave. Ooh, got a lady coming over. Have a good night, Keith. I'll see you around. I think I'm gonna do 20 bars across. And I'm going to do this like this, so x bigger than the width, then x plus equals, how big do you want the stride to be? I'm going to do 50. Okay, and then we're going to need to move the position and extension based off of this. So the x is actually going to be constant for these. The x plus the step. I can also add a bit of rounding, but I'm not going to. I'm gonna make it red. So, actually I was going to test this now, but I'm just going to calculate the sine value here. So x times whatever frequency we want. And then the height, yeah, we want to convert this as well. The height like this. So now this value will go, this converts it from 0 to 1, and then this scales it to the pixel value across the height. So then our position becomes value times 2, or actually both these become value too, because the extent is half and the position is halfway. So there we go, that should render it. Boom, there we go. So that renders a very simple sine wave. I'm gonna make the frequency a bit bigger and make the bar size a bit smaller. Alright, I'm happy with that. Now we're going to draw a little label. And I think the text is going to be blue. No. Wait a minute. This is wrong. This is supposed to be outputting red and it's outputting blue, which means that the red, green, and blue in this bitmap helper are flipped. And here I swap them, but I'm not swapping them here. Anyways, I will draw this label. And then we will test this. Oh, that's the text thickness right here. Should fix it. There we go. Label. Okay, so now I need to actually make the red, green, and blue properly. So I am wondering if right here, if I need to flip this for not just the red, green, blue, but I don't see why I wouldn't need to flip this for the 4 bits per pixel as well. We'll test it here. I'll try saving this as a 4 bytes per pixel. Oh my god, okay, so this only saves. I understand this now, actually. Oh my god, okay, this is only saving. Only saving is 3 bytes per pixel or 24 bit per pixel. So I'm thinking this might actually be more optimized if instead of writing bytes, I write to a buffer like this. Write each line to a buffer. I think this is actually best. Alright, so then for each line we combine all the data into this aligned. Here we go, and now I can do swapping as well. Oh wait, this is going backwards. What in the fuck? Why is this going backwards? Oh, it's the vertical flip. Oh, okay. What did I do for this? Oh, they all just equal the single value. Okay. This should do it. Boom! Oh no, now it's backwards. Fuck. Wait a minute. Hold on a second. How does that result in it being flipped? Wait a goddamn minute. I'm actually so confused. Because going backwards here is what makes it, oh should be what does it. Let me actually go back, let me look at my old code here. Minus equals W3. I think this is wrong. Doing it the same as before, swapping 0 and 2. Yeah, so swapping 0 and 2 should flip the color, but it shouldn't flip the position. What I think I'm doing wrong is right here. I think both these can be this. But yeah, the flipping 2 and 0 flips the color. Yeah, this is 100% flipped. Because I am not inverting this here. Hi, Gianmarco. Yeah, I'll try flipping 0 and 2 here. Yeah, you can ask any... Go ahead and ask. So yeah, this just flips the color. But that's so interesting how it's not flipped like the other one. What is different about the code here? Oh. Writes it raw. Can you program for C++? Yup. I just avoid it unless I have to. There's a few libraries that you have to use C++ for. Actually, yeah, my stream the other day when I was doing the audio feedback or visualizer, I had to use a C++ API from C, accessing the virtual tables and stuff directly. Okay, so This is doing vertical flip. But I'm fucking up and I'm also doing, so just writing it... Yeah, shit. I gotta do a bunch of swizzling for this and rewrite it. I see what I have to do. Instead of backing up here, I need to go forward. Or I need to back up to do the vertical flip, but then go forward right here and do like plus equals 3. Can you help me understand anything in code? Sure. And then data here is represented as a row. Starts out down 1 row. Some paste spinners, there's stuff that will block me. Yeah, you could send a paste spin, you could post it on Discord. I don't have any link protection here, so it won't block you. Or at least I don't have link protection on right now. A, B, C. What the hell is this code doing? That's, that's some obfuscated code. It has basically no naming or anything. Is that a Fourier transform, actually? It's a school project, it's not complete. Man, I have no idea what that does. Alright, so go down by the row size here. This, okay, this should do it. I don't understand the cast. You can't just convert for an integer depending on the inputs. It could be a long. Yeah, that's just like the compiler. It's, yeah, like it's not like it's the absolute value function. Doesn't have like a specific type. And it's ambiguous between long and... There we go! Hell yes. Okay. Here we go. So it's outputting the proper red values. If I cast it to short, it gives me a runtime error. I don't know. I do not know. That is something to do with how it's using the number and it overflowing or something like that. Alright, so all of this should work then. Boom. There we go. We fixed our bitmap saving. So this is also why I write these examples. Is like, for all I know, there can be bugs in this until I test them like that. So I've just tested the load bitmap function there. I never tested this save bitmap, at least thoroughly, so... Okay, we're gonna put this label, the top 20 pixels, the graph, height. Is that not the position? Did I not save or what? Oh, I guess I didn't save. Oh, that's a bit too high up. Yeah, actually, I'm gonna put the label down here. Reference is short. I converting an int. I think it's because calling size on string returning size t is the y casting into a short cause crash. I'm just thinking if the value overflows above the short value, that's why it would cause a crash. Or some compilers like C++ are set to throw exceptions on integer overflows, which would stop your program. Alright, boom. There's a nice example. Oops. Boom. There's a nice example of writing a little graphing program in C. I think that is a nice little example. It's like 40 lines, 15 lines. Shows you how to do a nice little bar graph of a sine wave, draw a label. And this is all software based. You don't need any OpenGL or anything to render these graphs. Then it just outputs the pixel buffer to a file. And see it overriding previous stuff I casted to show if the strings were 164 kilobytes. Yeah. Okay, it's a working example. Got that done. I'm wondering actually if I should go through and fix up some of these other ones at some point. I'm gonna go have dinner though. Thank you to anyone who watched the stream. I will be back again tonight for more of this programming. Hopefully to get into some game dev soon. One of the examples I want to make is Pong, to show people how to actually make a game with these things, so that should be fun, but I have to get through all this boring stuff like the graphing and things before I get there. Thank you to anyone who watched though. Hope you enjoy this as much as I do. I will see you guys around. Have a good day, good evening, wherever you are.